Oh, well. Hello, hello. Some of you might have a question. Just one. That's understandable. Wait until the end of the talk. You're going to have many more questions. Trust me. We actually asked not to introduce us because, frankly, in this form, shape, it wouldn't cut it. So we'll introduce each other.
All right. I think we need the slides first. Can we get the slides, maybe?
Oh, we don't have slides.
All right.
Awesome. So to the right of me, you can see, observe, banana number 1. Outside of tiny banana circles, he's known as Pablo. Some people think he's Python core developer and steering council member. He is also doing exquisite engineering at Bloomberg. He's also a theoretical certified pomologist. In Python, he was responsible for improving Python parser, formalizing f-strings, improving error reporting, improving debuggers, and profilers.
Here, as you can see, I have banana number 2. He says that he's a core developer, but you will tell me if he looks like one. Hopefully not. He also says that he's the CEO at Gel Data. We will ask his employees what they think about his costume. And the damage inflicted on Python is very numerous, including Asyncio, async-await. He's also the author of context bars, and 2 libraries that a lot of you probably are using, SymPG and UVloop.
Now, sadly, it should have been 3 of us on the stage. There's one missing banana. Lukas Lange helped a lot with what you're about to see. Unfortunately, due to PyCon US rules, only 2 bananas can be presenting on stage. So sorry, Łukasz, next time. Anyway, let's start from the beginning. This weird story starts, like many weird stories, at Meta headquarters in Seattle. So we were part of Python core development sprint. And this is, by the way, why you should become a Python core developer. It's a very rewarding job. But also then you can come to all those big companies and do the work for free. So I was thinking what I should be doing at the sprint. And I stumbled upon this little issue opened by Meta employees. They wanted to introspect async I/O programs without any overhead. They want to use this space-age technology called eBPF profiling, which essentially allows you to sample your process, look inside its memory, extract information, store it in the database, accumulate statistics, analyze it later. It's amazing, 0 overhead. But unfortunately, if you just point that profiler, that kind of profiler to an async program, you will see probably not something that's very interesting. Pablo?
So let me show you the problem. So let's imagine that you have this async problem. It does a bunch of tasks, and it does a bunch of things. It does like an enterprise-wide sleep over there. Not very important. It's so much not important that it's not even syntax highlighted. But the important thing is that if you have this running on the background, and then you point to this, one of these programs that will tell you the Python stack, or you look at the Python stack from outside, you will see this, which, you know, it kind of looks like something that you could use, but if you look at this like for a long time, you will notice that it doesn't really look good. In particular, you will see that most of the frames here are in the asyncio standard library. In fact, there is no trace of the actual tasks that are running. I even put cute names to those tasks and they don't appear here. The only frame that is in your code is asyncio run main, which is kind of like not super useful. If this is confusing for you, let me tell you what is the technical term. The technical term for this is useless.
So back to square one. I was looking at this issue, and I thought, hey, I already have some ideas on how to implement this. I have no idea how eBPF profiling works, so I need help from a banana man number 1 in this case. And I thought that we can be done with this in just a couple of days. By the end of the sprint, we would have the pull request merged. Easy victory. Or maybe I can even pull it off in like 1 hour of focused work. But nothing, absolutely nothing, could have prepared us for what happened next. Behind me, you can see the actual pull request scrolling by. This is probably the most reviewed pull request in the CPython history, 16 approvals. Funny thing, the screenshot is 1,000 pixels wide and 100,000 pixels tall. It crushed professional Hollywood software Houdini, DaVinci Resolve, when I tried to animate this screenshot 3 times. iMovie did the trick, though. Anyway.
So 100,000 is not even the biggest number that you will hear in this talk. We are going to go from things that take milliseconds long to things that will take to the heat death of the universe. But the important thing is that we clearly exit this process totally sane, as you can see, like no problem whatsoever.
Anyway, what's on the menu of this talk besides this 2 awesome, delicious bananas? Well, first, we're going to talk about Asyncio. We're going to tell you how it works. We're going to tell you what are tasks, what are coroutines, how they are related to each other. Then we're going to tell you how to solve Meta's problem in a bad way, like literally first attempt way. And then we're going to tell you how to solve this problem in a horrible way.
We call it the way.
Anyway, Asyncio is actually quite simple. But somehow, a lot of people are scared of it. And it bums us. Because we spent so much time improving Asyncio docs. Personally, me and Pablo helped. We think it's approachable, it's readable. Anybody can understand Asyncio just by reading docs. Somehow people don't do this. So I'm going to prove all of you wrong right now. I'm just going to read Asyncio docs out loud, and you will understand it. So Asyncio is just a hypermodular, polyphasic chrono orchestrator. It's a self-spinning event loop cyclotron that continuously interrogates heterogeneous I/O flux channels while creating a lock-free nanobatch of callbacks micro-ops inside the latency adaptive ring
I think
buffer.
they can read the docs later.
OK.
All right, all right.
Anyway, Asyncio is actually simple. Pablo is about to explain it to you. But it's a simple event loop that you don't want to use directly. So you want to use async await code. I asked Pablo to draw an illustration of Asyncio loop, and this is his best effort. I'm not even sure what this is. Can anybody find a loop here?
It's an arrow. Like you curve the arrow, it's kind of a loop. But seriously, what I wanted to show here with this like enterprise-wide, artistic software is that Asyncio is basically like a queue, and like the queue contains basically callbacks. And the idea of the Asyncio loop is that it will wait for something to happen on the network, calling epoll or any of the selector calls, or maybe some timeout to happen, and then it will enqueue all the callbacks from the queue, and it will just call them. That basically is what it is.
So anyway. Asyncio is what you actually want to use instead of callbacks, instead of interacting with the event loop directly. But funny enough, async await is actually callbacks. It's callbacks all the way down. And so back to square one. Let's unwind.
So it's actually not complicated because like async functions are basically like generators. They not only look similar, but they are basically functionally the same. Actually, you can see it with a simple example. So imagine that you're in the REPL and you create one of these generators. So if you actually call like this function, nothing actually happened, obviously, because like it's a generator. If it's a coroutine with async instead of like def, you will receive a coroutine object here. And then, because this is a coroutine, nothing happens when you call it. You need to actually drive it. And this is what the even loop will look like. So in this particular case, we start the coroutine by sending something to it. So we send none. And we can see that the coroutine runs until the yield point. If this were a Asyncio function, then this will yield to the even loop something to wait on. And once the even loop sees that this is ready, it will send back the result. Here the result is none, but you can see that then we print. And like in this particular case, we raise a stop iteration. So some people will say that this is enterprise software, so maybe you don't want to actually use the REPL to run an Asyncio program. So we need some structure to actually do this send for us, and that is called Asyncio tasks.
So basically, Asyncio tasks are wrapper objects. They wrap the underlying low-level coroutine. They call the send method. They have a special wake-up method that the event loop will call. This is the callback. To drive your async await spaghetti, really. And tasks are pretty much units of work. You can conceptualize them as such. So for example, if you have a cron job or maybe an API handler, your coroutine that does that work will be wrapped in a task. Tasks are quite similar to OS processes and threads. So tasks are completely independent of other tasks. They know nothing about other tasks. They know nothing about their children. They know nothing about their parents. Don't be an async.io task. So when I was thinking about this, I realized that to solve this problem, we need to somehow stitch tasks together to actually break this vicious cycle. We need to teach them, give them some extra awareness of what's around them. And the solution is to actually have this little new attribute that we added, task awaited by. So while the task is being executed, we know that it's being awaited by something, and we populate this attribute. And this is how we can basically give like a graph-like understanding to a task of its surroundings. So we ship these two new exquisite, beautiful APIs. One of them is print task call graph. The other one is capture call graph. Basically, you can call them from your Asyncio program, and they will do the trick for you. So in fact, we are ready now to demonstrate you how to do Asyncio introspection in a bad way. So what you can have a loop in your Asyncio program, a task that just slips, periodically captures the tasks, saves it to Dropbox paper, and we can call it a day. Aside from this being just immensely stupid to save it to Dropbox paper, this is also going to be slow, so we don't want to do this. So let's talk about how to do it in a horrible way.
All right. So the problem here is that these functions that we added, they need the actual task to start to work. So you need to give the task. And unfortunately, you can only do this thing from within the process. So if you want to use these functions, you need to call something in the process. And that is forcing the process to do something else. And that is slow, and we don't want this. So to make this really good and to make introspection nice and to build profilers and other tools, we need to do this thing from a different process in a way that has zero overhead. So this horrible way, we call it our way. So to show you how we are doing this, imagine that you have a complicated Asyncio program. These bits can get really, really nasty. In this particular case, even if it's very few lines, we are creating a task, and we are passing that task to another two tasks that they are waiting on it through many coroutines. So even these many lines of code already creates a tree of dependencies that is quite bad. So if you throw the same programs that show you the Python stack to this, and then you capture it in a moment when Asyncio is running, you will see two different phases. You will see code that is in your file. You can see a bunch of coroutines here and a sleep above there. But I have three tasks here, and I can only see coroutines. So there is a lot of information missing. Not only that, above it is the even loop. So we need to use the functions that we have. We need to find the task. So the way we proceed is actually quite simple. We start from the bottom frame, and from the bottom frame, we can follow the linked list of frames and to ask who is the caller. So it's the coroutine C4, then the coroutine C3, then C2, and then we find the first even loop frame. So this is the place where we already don't care. And now we need a way to go from the last coroutine to the task that is running. To do this, we use something that will drive you crazy or convert you into banana, so we don't want that for you. It's technology that will drive Mark Shannon quite crazy, but let's skip it over there and let's pretend that it's this arrow. And then somehow we go from the coroutine to the task that is running it. So now we have it here. And once we have the task, using this new Asyncio awaited by, we can know that this task is awaited by three tasks. And following these arrows of coroutines and using the new awaited by, we can actually start resolving all the people that are awaiting these different coroutines until we have this tree of dependencies, which is what actually you want. And you can see here how already this is quite complicated because it involves frames, tasks, coroutines, and then you need to jump from the Python stack to the world of coroutines and whatnot. And if you think this is complicated enough, remember that this is made from one process to the other one. So every arrow that you saw in the previous slide is actually a copy across processes. So to do that, we need to use this hacker-only certified system call called process vm-readb that will basically reach across the void from one process to the other. It will grab memory, and it will have to reinterpret the whole thing, which is quite heavy metal.
All right, honestly, it was all great. Until Lukasz, for some unknown reason, decided to test the thing. Never do this to your friends. Don't test their code. Shame on you, Lukasz, but thank you. So anyway, what happened next is that he wrote a simple program, pointed our new tooling to it, and saw nothing. Absolutely nothing.
The technical term is no bueno.
What followed can only be described as existential despair and a shared sense of total helplessness among the three of us. We quickly realized, though, that everything works as expected. Pablo is about to explain UI.
So the problem is that when Asyncio starts to run things, like it will run one of these tasks. Let's imagine that it's task 12 over there. But then when it's finished to run whatever the code is, it needs to wait for some I/O to happen or for some time I/O to happen. So when this is happening, it's just the event loop waiting for it. So this is when you only see event loop frames there, like no trace of any of the task. And when something actually happens, then it goes and runs some other different task. And then it waits for something to happen. Just the event loop here. And then another task graph. And then nothing to happen. So this is the problem. The problem is that when Gukesh Langa, banana number 3, was trying this code, he was running it in this moment when only the event loop is there. So there is no way for us to grab any of the tasks because all the tasks are being awaiting.
So believe it or not, this is totally fine. You can just like point a profiler to Asyncio program, capture what it's doing right now, and expect to see something. You will only see something when you do it continuously. Like this is what Meta wants to do, like point the BPF profiler and just like capture the information, aggregate the data. Some of those snapshots will actually include the current tasks. And in time, you will have enough statistics to see which tasks are slow, which tasks are fast, what parts of your program deserve extra attention. So just in order to make this talk fun, we realized that we need to give you some tools that you can use for your Asyncio code without resorting to something like eBPF. So we decided to implement something like a PS command, but for Asyncio. Lucas volunteered to implement the command. There was only one little problem.
Gukesh Langa created the worst data structure of the universe.
We actually have a secret recording video feed, essentially, of what happened. So here's Lucas descending to help us with the data structure. And this is what happened when we discovered how it actually works.
All right, so let me show you what is the problem. So with the program before, like this is only 3 tasks over here, a bit complicated. My task was to receive the most horrible data structure of the universe and pretty print it. Very easy. So this is what the horrible data structure looks like. It's kind of wild. It's barely better than Lisp. And when you look at it, you see a bunch of weird stuff. In particular, main appears 6 times for some reason. Like, it's kind of weird. So I spent 20 minutes looking at this, and then I did the only thing that you can do these days, ask a stupid robot about like what is going on. So I asked ChatGPT about it, and this is what ChatGPT told me. It says that it should be better to consult an expert who specializes in this type of data structure format.
But Lucas is the expert.
All right, thanks. So after spending some time looking at LLMs, I actually realized that the problem is that this is generating all possible subgraph of the full graph. This is so stupid that we can name this algorithm, and we name it whole topology flood. And when you create a new algorithm, you are supposed to basically calculate the ON. So I did some math, and I modeled this as a graph of nodes, and the amount of subgraph of the DEG has this formula. Looks quite complicated, so let me give it to you in big O notation. This is big O 2 to the power of n to the power of 2. So if you think this is small, let me give you some numbers. With n equals 24, there are many task atoms in the universe. So my American friends will surely call this a good start.
So anyway, we had some fun. We fixed the code. So now it's time for the live demo. Except banana number 1 chickened out. So it's time for recording of the live demo.
All right, let me show you how the tool looks like. Awesome. So imagine that you have an Asyncio program. Here is the program from before, it's just the text. And now we run this program. And imagine that you don't know what is happening. So we need the PID, so I'm going to suspend it. I'm grabbing the PID, and then you can run this new program, is Asyncio PS3, and then you give the PID, and then you do this beautiful, beautiful tree representation over what is going on. If you don't like trees for some reason, we have a table for you, so you can look like an accountant. And we have this many relations in between all the tasks, so every single await will appear there, and all the relations in between the coroutine between the nodes. So you can reconstruct the tree if you want and say that you did it and not me. This is obviously just a building block, right? So it's helpful to know what the hell is running on a Asyncio program and to get a tree representation of it. But to give you a sneak peek of what we can build and we plan to build after this, you can actually use this for something a bit more tricky. So for instance, I'm going to run on the left a more complicated Asyncio program, which is the test suite of CPython. I should say a scary Asyncio program, maybe. So I can run the PID here, and instead of running it once, I'm going to just run it in a loop. So when you run it in a loop, I'm going to use the watch command. You can see in real time how the program is changing and how the coroutines are just changing. And you can see this graph, this previous plot that I showed you as they go. So with this is just for entertainment purposes, but if you start dumping this to a disk or to Dropbox paper, you can actually build a profiler out of this. The first ever Asyncio profiler that is able to see all the task relationships with zero overhead, because the other guy doesn't even know that it's happening.
All right. So what did we just see? Apparently, all you need is Python 3.14, async await spaghetti, a PID, and a healthy yellow stack. To sum it up, we just saw that you can get the coroutine stack frame of Asyncio programs. All tasks and coroutines and dependencies between them are resolved. It works between processes and at zero overhead. So here we are, two delicious, humble bananas. We went through hell to give this to you. We fought for you in the most reviewed PR on GitHub. We survived the whole topology flat algorithm and witnessed the heat death of the universe. This ships in Python 3.14. We hope you like it. Happy debugging. We just happen to know that there is one banana that wants to ask a question.
So we have some banana. We summon the banana.
Banana.
It's a bit shy. It's a bit shy.
First appearance.
Don't worry, we have time. All right, all right, all right. A big applause to the extra banana. I think you need the banana mic. Yeah.
Thank you for being snappy.
So what is your question, banana?
I have just one question. So all of this is cool and fix my ingenious algorithm and data structure, but what does the author of Asyncio think about all of this?
That's a very good question. You see, I'm not the author of Asyncio, right?
So who is the author of Asyncio?
Who is the author of Asyncio?
Is there a fourth banana?
Is there a fourth banana in the room?
Yes. So Guido, what do you think about all of this?
I think it's totally bananas.
This is it. Thank you, guys.